press the bell icon on the YouTube app and never miss another update.
Good morning, students. In the yesterday class, we have discussed about principle of superposition of waves and some sources and properties of the two important waves around us, which we make use in our day-to-day life while hearing the information or while seeing the objects, right? Again, information. And now let us solve some numerical problems on waves, right? So first of all, we will write down the formulae used in this chapter. Now, the first one again that we have used in oscillations, that is frequency is equal to 1 by T or T is equal to 1 by F, and W is equal to 2 pi by T and B omega is equal to 2 pi F. Now, the second equation, we have the relation for wave velocity. Wave velocity is given by V is equal to lambda by T, where lambda is a wavelength of wave and T is wave period. And again we have V is equal to lambda into F, where F is a frequency. Now, number 3, we have a wave equation. So, the standard form of wave equation, Y is equal to A sin omega t minus kx, B y is equal to A sin 2 pi by lambda into T by T minus, right, x by lambda. C y is equal to A sin, right, omega into T minus x by V, but these equations can be changed or modified according to the requirement of the numerical formula and the given equation of progressive wave. Now, fourth one here, we have a propagation constant and also called as wave number. K is equal to omega by V, or K is equal to 2 pi by lambda. Now see, in the general equation, this omega represents period or frequency and K represents a wavelength of wave. Now the fifth one, we have, right, A, the distance of the particle from the origin, x is equal to, right, lambda by 2 pi into phi, where phi is the phase of the particle at a distance x from the origin, and we have the relation between, right, phase difference and path difference, right. Delta phi is equal to 2 pi by lambda into delta x. Here delta phi is the difference between the phase difference between two vibrating particles. Delta x is the path difference between the particles. Here x is the distance of the particle from the origin and phi is the phase of the particle. Right. Now, right. The sixth one we have, right, intensity I is equal to P by A, where I is intensity, P is power of the source producing the progressive wave, and A is area of cross section of the surface over which it is falling, right? And also this intensity is given by I is equal to 2 pi square A square F square, right, V into rho. For a given wave in a given medium, 2 pi square is constant. For given wave, F is constant. In a given medium, V and rho are constant. Therefore, intensity is directly proportional to A square for a given wave in a given medium, right? So, these are all the main formulas which we are using to solve numerical problems in waves, and sometimes depending upon the requirement of the numerical problem, we may have to modify this right formula. Right? So now we will take numerical problems. So I will write it on the board, then I will solve it, right? Now the problem number 1, right? The frequency, right, of a progressive wave is 340 hertz. If it has a wavelength of, right, 0.2 meter, find velocity of wave, right, in the medium. Right. Now the problem is, we have given the frequency of a progressive wave is 340 hertz. If it has a wavelength of 0.2 meter, find velocity of wave in medium. Now we have given the data, right? Here we have given the frequency, F is equal to 340 hertz, right, and wavelength lambda is equal to 0.2 meter. Now we need to find velocity V is equal to what? It is a simple problem. Now we have velocity V is equal to lambda into F, or V is equal to lambda 0.2 into, right, frequency 340, or V is equal to 2 into 34, or V is equal to 68 meter per second. So velocity of the given wave is comes out to be 68 meter per second. Now, the second problem, the frequency of a tuning fork is 275 hertz. The sound travels a distance of 5 meter while the fork completes 4 vibrations. Find a wavelength of sound and B speed of sound. Right. Now we have given the frequency of a tuning fork is 275 hertz. The sound travels a distance of 5 meter while the fork completes 4 vibrations. Find A, right, wavelength of sound, and B, speed of sound. Now we have given data, right. The frequency of tuning fork is 275 hertz. So when it is set into vibration, it produces sound waves of frequency 275 hertz, right. And here, right, he has given distance traveled is equal to 5 meter, number of vibrations is equal to 4. Now what we need to find? Speed or velocity of sound V is equal to what? And we have given the frequency. We need to find velocity. To find velocity with the help of frequency, we need a wavelength, right? Again here we need to find wavelength, right? Lambda is equal to what? How to find wavelength? We know that wavelength is the distance travelled by a wave in a time interval equal to its period. In a time interval equal to its period, right, the particles complete one vibration, right? That means to say, when the particle completes one vibration, right, the distance moved by the wave is equal to wavelength. Therefore, we can write wavelength is equal to distance travelled by number of vibration. It is entirely a new formula, right? We have obtained depending upon the requirement of the problem, right? When number of vibration is equal to 1, distance travelled is equal to wavelength. Now that lambda is equal to distance travelled 5 meter divided by number of vibration 4, that is equal to 1.25 meter. So we have found the wavelength of the wave, it comes out to be 1.25 meter. Now velocity v is equal to, right, lambda into f, that is lambda 1.25 into, right, it is 275, and it comes out to be, right, 343.7 meter. When I multiplied it, it comes out to be 343.7 meter per second square. See here, to find the velocity we required, right, wavelength, because frequency is given, but the wavelength is not given directly. He has given distance travelled by the wave as well as number of vibrations. So with the help of the distance travelled and the number of vibration, we have found the wavelength. After finding the wavelength, it will be easier to find the velocity. Is that clear? Now problem number 3. The equation of a simple harmonic wave is represented by y is equal to 0.5 sine 314t minus 1.25x, where x and y are in meter and t is in second. Right. Now, so calculate amplitude angular frequency, comma, frequency, comma, time period, comma, propagation constant, and speed of wave. Now, so carefully read the problem. The equation of a simple harmonic wave is represented by y is equal to 0.5 sine 314t minus 1.25x, where the distances x and y are in meter and t is in second. Calculate amplitude, angular frequency, frequency, time period, propagation constant, and speed of wave. Right? Now, in this problem, we have given a wave which is represented by a wave equation, right, given in the problem, and we need to find the wave parameters. Right? Now we have given y is equal to a sine 314t minus 1.25x. So we need to find amplitude A is equal to what? Angular velocity omega is equal to what? Frequency f is equal to what? Right? Time period t is equal to what? Propagation constant k is equal to what? And wave velocity v is equal to what? Now we have standard equation y is equal to. You just carefully observe that one. We have three standard form of wave equations. Here we have y is equal to a sin 314t minus 1.25x. Right? Now when we compare this equation with our standard equation, it can be comparable with a sin omega t minus kx. This is given equation 1, this is 2. Now comparing equations 1 and 2. Right, now this is not, this is 0.5. Now comparing that, we got amplitude A is equal to, right, 0.5 meter. Amplitude A is equal to 0.5 meter. Now omega is equal to 314 radian per second. Now k, that is propagation constant, that is equal to 1.25 radian per meter. Then now to find the frequency, we have omega is equal to 2 pi f, or f is equal to omega by 2 pi. So f is equal to 314 divided by 2 into 3.14. That is f is equal to 3.14. When 314 divided by 3.14, we get 100. 100 by 2. This comes out to be 50 hertz. Now t, we have t is equal to 1 by f, that is equal to 1 by 50, or t comes out to be 0.2 second. So again we left with v. We have k is equal to, right, k is equal to omega by v, or v is equal to omega by k, that is omega 314 divided by this 1.25. So we get that wave velocity v is equal to, right, 251 meter per second. Right. Now carefully observe this problem. So it is one of the standard type of numerical problem in progressive waves. So in this type of numerical problems, right, a wave equation is given and asked to find wave parameters such as amplitude, frequency, wave velocity, angular velocity, right, propagation constant, etc. Right. So in that case, right, the procedure is simple, right. Compare the given equation with the standard equation. Sometimes we can directly compare the given equation with the standard equation, or sometimes, right, we have to modify the given equation, right, so that we can compare it with a standard equation, right? Now, the problem number 4. A progressive wave in a string is represented by y is equal to 0.6 sin pi into 2t by 0.01 minus x by 2. Find amplitude wavelength frequency period and wave velocity, right. Again we see, right, given equation y is equal to 0.6 sin pi. Now 2t by 0.01 minus x by 2. This is the given equation. As usual, we need to find amplitude A is equal to what? Wavelength lambda is equal to what? Frequency f is equal to what? Time period t is equal to what? Right? And wave velocity v is equal to what? Now we have the standard equation, right? Y is equal to, right, y is equal to a sin, right, 2 pi by lambda into t by t minus, right, 2 pi into t by t minus x by lambda. It is one of our standard equation, right. So this equation straight away cannot compare with the standard equation. So let us modify this equation. So now this equation y is can be written as 0.6 sin. We need 2 pi here because the standard equation has 2. Then taking 2 here, 2 pi, now this becomes t by 0.01 because I have taken 2 outside. When I take this 2 outside, this becomes x by 4, becomes it is 2x by 2 into 2 is taken outside. Now this is equation 1. Now we have standard equation y is equal to a sin 2 pi into t by t minus x by lambda, equation 2. Now comparing equations 1, and 2. In the previous problem, the given equation itself is directly comparable with one of the standard equations. But in this numerical problem, right, to compare it with one of the standard equations, we have to modify that equation, right? Now, so remaining thing is as usual, A is equal to 0.6 meter. Why I am writing meter? If any unit is not mentioned in problem number 3, right, along with the equation they have mentioned the factor that x and y are in meter and t is in second. Sometimes x and y may be in centimeter or millimeter, right? But here nothing is given about the unit, so that we can consider the SI unit. Now the next thing we need wavelength. Straight away, wavelength lambda is equal to 4 meter. Now t is equal to 0.01 second. Now frequency f is equal to 1 by t, that is equal to 1 by 0.01, or frequency f is equal to, right, 100 hertz. Now wave velocity v is equal to lambda into f, that is 4 into 100, that is equal to 400 meter per second, right? Have you seen the difference between problem number 4 and problem number 5? Problem number 4, the given equation straight away comparable with one of the standard equation. In this numerical problem, problem number 4, we have adjusted or modified the given equation so that we can compare it with one of the standard equations, right? So that you have to remember, right? Now problem number 5. Find amplitude frequency period wavelength and wave velocity in the equation y is equal to 0.04 sin 2 pi by 0.01 into t minus x by 0.3. Now see the given equation. Again we have given an equation, we need to find amplitude etc. Now the factors to be found: amplitude A is equal to what? Frequency f is equal to what? Period t is equal to what? Wavelength lambda is equal to what? And wave velocity v is equal to what? Now given equation y is equal to 0.04 sin 2 pi by 0.01 into t minus x by 0.3. Now we have the standard equation, right? Y is equal to a sin x a sin omega into t minus x by v. Let us take this as equation 1. See here, now here we have 2 pi by 0.01, here we have omega. Let us modify this standard equation. A is equal to, y is equal to a sin. This omega can be written as 2 pi by t, we can write it as 2 pi by t, and this is t minus x by v. Now in this case we have altered the standard equation, so we replace this omega by 2 pi by t, then we can compare with the given equation. Now comparing equations 1 and 2, we get amplitude A is equal to 0.04 meter, time period t is equal to, right, 0.01 second, and velocity v is equal to 0.3 meter per second, right. Now the remaining thing is we have a frequency f is equal to 1 by t, or f is equal to 1 by 0.01, or f is equal to 100 hertz. Now we need to find the wavelength. We have velocity v is equal to lambda into f, or lambda is equal to, right, v by f, that is equal to 0.3 by 100, that is lambda is equal to 0.003 meter, right. So what we have learnt in this problem, the procedure is almost the same, comparing the given equation with standard equation and finding the wave parameters. But in this problem, problem number 5, we have modified the standard equation. In problem number 4, we have modified the given equation. So whatever may be the requirement of the problem, whether we have to compare, we have to modify the given equation in the numerical problem, or we have to modify the standard equation, but the two equations should be comparable. Then only we can get the correct values of wave parameters. Right. Now, problem number 6. Right. A simple harmonic wave traveling along positive x direction has an amplitude of 0.05 meter, a wavelength of 0.5 meter, and frequency of 20 hertz. Frequency of 20 hertz. Find the wave number period angular frequency and wave velocity. Right. Now, once again we will read that problem. A simple harmonic wave traveling along positive x direction has an amplitude of 0.05 meter, a wavelength of 0.5 meter and frequency of 20 hertz. Find the wave number, period, angular frequency and wave velocity. See here, the given data, right. Now amplitude A is equal to 0.05 meter. Wavelength lambda is equal to 0.5 meter. And frequency f is equal to 20 hertz. Now what we need to calculate? We need to calculate wave number. Wave number means here propagation constant. K is equal to what? Period T is equal to what? Angular frequency omega is equal to what? And wave velocity v is equal to what? So here in the problem we have given a simple harmonic wave and its wave parameters, right, like frequency, wavelength and amplitude. Using that we need to find the other parameters of the wave, that is k, t, omega and v. So in this case we need not have to use the wave equation because right in this problem, right, no wave equation is given, right. Therefore using the relation between the parameters, right, now we have k is equal to 2 pi by lambda. So k is equal to 2 into 3.14 and divided by, right, 0.5 meter, right. This comes out to be, right, k is equal to 12.56 radian per meter. Now the time period t is equal to 1 by f or t is equal to 1 by 20, that is equal to 0.5 second. Now we need to find omega. Omega is equal to 2 pi f. Omega is equal to 2 into 3.14 into, when we are calculating a physical quantity other than angle, you have to substitute the value of pi is equal to 3.14. When we are finding the angle, then you can substitute 3.14, we will get angle in terms of unit radian, or if you substitute 180 degree, then we will get the angle in terms of degrees, right. Now that omega is equal to 2 pi f, that omega comes out to be 120, this is 20, 125.6 radian per second. Now, velocity v is equal to lambda into f. Velocity v is equal to lambda into f. V is equal to lambda 0.5 into frequency 20. That is, velocity v is equal to 10 meter per second. So, we have solved this problem. In this problem, some wave parameters are given and the other wave parameters have to be calculated. Now, problem number 7. A sinusoidal wave propagating through air has a frequency of 180 hertz. If the speed of wave is 360 meter per second, how far apart are the two particles vibrating in medium with phase of 45 degree and 60 degree. Right. Now, we have given data. The problem is a sinusoidal wave propagating through air has a frequency of 180 hertz. If the speed of wave is 360 meter per second, how far apart are the two particles vibrating in a medium with a phase of 45 degree and 60 degree? Let us understand the problem with the help of a diagram. Now, a wave is represented like that. Here there is a particle having a phase of 45 degree, that is at a distance x1, and here we have another problem having a phase difference of 60 at a distance x2. Right? We need to find the distance between the two particles. One particle having a phase of 45 degree and the other particle is having a phase of 45 degree. Right? So we need to find delta x is equal to x2 minus x1 is equal to what? So given data, phi 1 is equal to 45 degree at x1 from origin, phi 2 is equal to 60 degree at x2. Right. So here the frequency f is equal to 180 hertz. Right. Speed of wave v is equal to, right, it is 360 meter per second. So you need to find delta x is equal to x2 minus x1 is equal to what? Right. Now, so we have the distance of the particle from the origin, x is equal to lambda by 2 pi into phi. I have given it in the list of formulae, but in theory classes, right, we have derived the relation between path difference and phase difference, right. So using for that one, we need to use the wavelength lambda, right. Now this phi 1 can be written as it is pi by 4, that is 45 degree. Phi 2 is equal to pi by 3, that is 60 degree, right. Now we have distance x1 is equal to, using this formula, right. We need to find lambda here, sorry, lambda. Here we have V is equal to lambda f, or lambda is equal to V by f, that is 360 divided by 180, that is equal to 2 meter. Now we have x1 is equal to lambda by 2 pi into phi 1. So x1 is equal to lambda 2 by 2 pi into pi by 4. Here pi get cancelled, 2 get cancelled. This is 0.25 meter. Now x2 is equal to lambda by 2 pi into, so phi 2, that implies x2 is equal to lambda 2 by 2 pi into 60 degree is equal to pi by 3. Pi get cancelled, 2 get cancelled, that is equal to 1 by 3, that is 0.333 meter. Therefore, write x2 minus x1, delta x is equal to x2 minus x1. When we substitute it, we will get 0.083 meter. So the distance between the two particles x2 minus x1 is 0.083 meter. Now you substitute the value here. Here x2 is equal to 0.333 meter and x1 is equal to 0.25 meter, right. So in this problem we have given frequency of wave, velocity of wave. Using that we found lambda, and using the relation between phase difference and path difference, right, we have found the distance between two vibrating particles. Now problem number 8, find phase difference between two particles two particles separated by a distance of separated by a distance of 0.5 meter in a wave represented by y is equal to 2 sine 5 pi t minus 0.2 pi x. Now in this problem, find phase difference between two particles separated by a distance of 0.5 meter in a wave represented by y is equal to 2 sine 5 pi t minus 0.2 pi x. So we have given data, right? So distance between two vibrating particles, that is path difference delta x is equal to 0.5 meter. Now we need to find corresponding phase difference delta phi is equal to what? And given equation y is equal to 2 sine 5 pi t minus 0.2 pi x. Let us take it as equation 1. We know that the relation between phase difference and path difference involves wavelength. Therefore, we need to find wavelength lambda is equal to what? With the standard equation, y is equal to a sine omega t minus kx, right? So comparing the given equation with the standard equation, we can able to find the value of lambda. We know that the k is related to lambda. We have k is equal to 0.2 pi, but k is also equal to 2 pi by lambda, or lambda is equal to 2 pi by k, that is 2 pi by 0.2 pi. Pi get cancelled, 2 by 0.2, 20 by 2, lambda is equal to 10 meter. So with the help of given equation, we have found the lambda value. Then we have path difference delta x is equal to lambda by 2 pi minimum. We need to find phase difference. So phase difference delta phi is equal to 2 pi by lambda into path difference, that is delta x. So delta phi is equal to 2 pi by 10 into 0.5. 2 into 0.5 is equal to 1. So delta phi is equal to pi by 10 radian, or delta phi is equal to 180 degree by 10, or it is equal to 18 degree. So phase difference when expressed in radian, this becomes pi by 10, that is 0.34 radian, and when expressed in degree, it comes out to be 18 degree, right? Now you just carefully observe the problem, how to analyze the problem and how to solve the problem. Okay, right? Now these are all the problems with waves, and in the next class we will take up the competitive part of this one. So thank you very much.